Okay, so yesterday we talked about the theorems of triangle proportionality. It's really building the foundation, the basement. Now we're actually going to apply that to some story problems, and this is like building the mansion, some really cool stuff on top of that foundation we built. All right, so indirect measurement, it's kind of self-explanatory. It's a method of using proportions to find unknown lengths or distances in similar figures. So you're indirectly measuring something. Directly measuring something is just using a tape measure or maybe some kind of fancy laser system. All right. There's two common ways to achieve indirect measurement. They involve using a mirror or shadow lengths. So it says read the paragraph on top of page 29. Let's just talk about a couple reasons. All right. Indirect measurement. It's really hard to measure like stars, planets. I don't think when we say the circumference of the moon or the diameter of Mars is this length, I don't think anyone really took a tape measure and measured it. All right, they used indirect measurement, and again, we'll talk about that for a long time, and maybe we'll touch on some of those techniques here in the notes. Maybe something awkward like a tree. All right, how do you measure the top of a tree? Well, I don't know. It's kind of hard to do, but you can use the shadow length of a tree in your own shadow, set up a proportion and all that stuff, or just a bunch of other awkward things. All right, maybe a really tall pole, a building, just a ton of stuff. All right, and we're really going to dive into that using this stuff right here. So George is 6 feet tall and his shadow is 10 feet long. At the same time, the shadow of the flagpole was 85 feet long. How tall is the flagpole? All right, so we got George's height, and we want to compare that to the height of the flagpole. George's shadow is 10. We know the height of the flagpole, so I can say, well, George is 6 feet tall and he has a 10-foot shadow. All right, we don't know the height of the flagpole, but we know it has an 85-foot shadow. All right, really, this is the bread and butter. If you can set this up, you're in really good shape. 6 times 85. All right, so it's going to be 10h equals 510. Divide both sides by 10. H is going to equal 51 feet. All right, so the flagpole was 51 feet. All right, so it would have been really hard to measure that with a tape measure. Again, tape measures are typically 25 feet long. So this is just a good way of indirectly figuring out the height of things. Kendall is 5.5 feet tall. She measured the shadow of a tree and found it was 5.5 feet long. She immediately measured her own shadow, which was 1.375 feet. How tall is the tree? All right, so a lot going on here. Let's just draw a quick, beautiful picture. All right, guys, I'm really good at drawing. Look how quickly I drew a really realistic tree. Look how really quickly I drew Kendall. All right. All right. She measured the shadow of a tree and found it was 5.5 feet long. So this is the shadow of the tree. It was 5.5 feet long. All right. Kendall was also 5.5 feet tall. All right. So as you can tell, I even drew this to scale. That's how good of a drawer I am. All right. Kendall's own shadow was 1.375 feet long. All right, how tall is the tree? All right, so let's just use Kendall. We know Kendall is 5.5 feet tall with a 1.375 foot shadow. We don't know the height of the tree, but we know the shadow was 5.5. So notice how the shadow's in the denominator of both fractions. Cross multiply. What is 5.5 squared? So we're going to get 1.375 t equals 30.25. Divide both sides by 1.375. And we find out the height of the tree was 22 feet all along. Nice. All right. Sweet. Cruising right along. To find the length of a pond, again, this is another reason why you might want to use indirect measurement. I don't know how you'd measure the length of a pond. It'd be really hard. All right, there's just a tape measure, but if you do it indirectly, it can be a little easier. All right. Find the length of a pond. A surveyor took some measurements and she recorded them on this diagram. What is the length of the pond? All right, so realize we know these two triangles have to be similar by angle. They both have a 90-degree angle and a 76-degree angle. All right, now we can say, well, let's just look at this top triangle. We have 3 and 12, so I'm going to say 3 over 12. I'm going to match up those corresponding parts. Now, what corresponds to 3? It's the 5 in this bottom triangle. Those are the corresponding parts. And then we want the length of the pond. We don't know that, so that's going to be 5 over P. Again, setting up this proportion, it's the hard part. If you can do it, excellent shape. All right, the pond's going to be 20 meters. It's actually kind of a decent sized pond. All right, reminds me of the pond on Frank's Park. If you walk behind over that bridge, it's probably about 20 meters long. No, actually that front, if I think about it, the front pond at Frank's Park, that's probably 20 meters. All right, I confused myself a minute. All right, now we're gonna relate this to photography. All right, some of you guys might have taken Mr. Volzer's fun photography class. Let's talk about that a little bit. The diagram below shows similar triangles formed by a camera and object in its field of view, FOV. If the working object distance is 10 inches, the image height sensor is 19.2 millimeters, and the focal length is 18 millimeters. What is the height of the object in inches? All right, so a lot going on in here. Let's just do some things, all right? So it says the working object distance is 10 inches. All right, the height in the sensor is 19.2, so this is very technical. I didn't know all this stuff about camera Russ. All right, and that's 18. So we're going to be able to quickly transfer from units to units. We're not going to really have to worry about that because this height over here, we're just going to say height in inches over 10 equals the sensor height, 19.2 over 18. All right, I'm not sure if this was drawn to scale, but regardless. All right, we're going to cross multiply 18h over 192. Divide both sides by 18. H equals 10.7. That's it. All right, that's the punchline. All right, let's do one more problem in this video. Don't want it to be too long. What distance should the photographer place the camera from the 24-foot tall tree if she wants the image of the height to be 56 millimeters? All right. Oh, looks like we can't do this problem. I accidentally cut it off. All right, we need more distance right there. Let's just skip this problem. Embarrassing, I cut off some of the problems. Skipping it, so sad. We'll just make up a number, 37. Why not? That sounds like a good number. All right, I'll have to fix that for next year. We'll do number 6 in the next video.